Hello and welcome to this video where we're going to talk about application security by first discussing some standard vocabulary for web application security risks and the OWASP top 10. So let's jump right in, because if you are new to this space, you probably are like, what on earth is an OWASP? So by the end of this video, what you will be able to understand or know more about is, one, what is OWASP? Why are there the top 10? And why does it matter? Right? We're going to kind of describe each one of them briefly in a quick tour. We're going to go over which categories are really the most relevant to the kind of code and projects you're working on right now. Give a concrete example of a vulnerability in each of the high relevance categories, and understand why security must be considered during development, not just at deployment. So let's get started by hopping into the 10 categories of the OWASP. And first, what is the OWASP? Well, OWASP stands for the Open Web Application Security Project. And the OWASP Top 10 is a standard awareness document for web application security risks. It is published by the Open Web Application Security Project, and it is updated periodically. The current version is 2021. And so you'll see this list referenced sometimes in job postings, security audits, compliance frameworks, pull request reviews, things like that. You don't need to memorize it, but you do need to recognize it and know which categories are most likely to affect the code that you write. We'll go over all of the categories real quick, and then we'll go deeper on those ones that are most relevant to you at your level. So you'll see they all have an identifier starting with A. So let's go real quick through what each one of these means. So an AO1 is a broken access control. So someone accesses data or performs actions they shouldn't be permitted to. This is one of the more common web vulnerabilities, and we'll talk about that one a little more in depth, along with AO2, which maybe run into cryptographic failures. So sensitive data, passwords, tokens, personally identifying things is transmitted or stored without adequate encryption. And this is what's really getting companies right now when they have data breaches, is they're not storing or transmitting your data safely. So when bad actors get access to the system, everything is just unencrypted in plain text. AO3 injection. This is user-supplied input that gets interpreted as code or a command, such as SQL injection, shell injection. This is a big one, and this is how a lot of bad actors gain access to applications and systems. AO4, insecure design. So this is where fundamental design flaws that no implementation fix can solve. The architecture is inherently insecure and should never have been built that way. AO5, security misconfiguration. Default credentials left in place, unnecessary features enabled, error messages exposing stack traces, missing headers. There's a lot of things that go into this, and this is a pretty common one, especially for newer developers. AO6, vulnerable and outdated components. Boy, this is a big one, and we've been seeing attacks coming straight through in our packages. And so we want to make sure that we're staying on top of, what third-party libraries have known security vulnerabilities, and that we're keeping them updated to address that. AO7, authentication and identification failures. This is things like weak session management, allowing credential stuffing, no multi-factor authentication. AO8, software and data integrity failures. So code and infrastructure that doesn't verify in its integrity. So using packages from untrusted sources. CI/DI pipeline tampering. It's definitely a concern, but at this level, probably not something you're responsible for. AO9, security logging and monitoring failures. So insufficient logging means breaches often go undetected. You're not alerting on suspicious activity. You could have bad actors in your application you wouldn't even know. And then A10, server-side request forgery, also abbreviated as SSRF. So the server is tricked into making requests to unintended locations. That could be internal services, cloud metadata endpoints. This can be a big one, but at this level, we're probably not going to talk about that one as much. So we're going to talk about some of the ones I've noted here, the 3 big ones that seem to come up a lot, especially with developers at this point. Now, maybe you are a more experienced developer and you're just learning about testing and DevOps and QA, and that's great. And you might know a little bit more about these than someone who is newer in their career. If so, I strongly encourage you to kind of leverage that information to start working on how you can make your application more secure in all 10 areas. But we're going to start with AO6, vulnerable and outdated components. And some of this is just because we have been seeing multiple types of attacks coming through outdated packages, compromised packages, and it's pretty concrete for students. So every package we install, the requests, PyTest, Newtonsoft JSON, things like that, are third party. So they're written by someone else and they may contain vulnerabilities. When a vulnerability is discovered, it gets a CVE number, that's common vulnerabilities and exposures, and a severity rating between critical, high, medium, and low. So if you're using a vulnerable version of a library and an attacker knows it, they can potentially exploit that vulnerability in your application. So a real-world example of this would be something like the Log4Shell that happened in 21. A vulnerability in the Java logging library, Log4j, had a CVE score of 10. That's the maximum possible. Millions of systems were using this and were vulnerable. Libraries you use daily can have this level of risk. And so things like requests in the library in Python has had multiple historical CVEs for SSL certificate verification issues. And so really, what can you do to protect yourself? Well, we want to keep dependencies updated and scan regularly to see, either using like pip audit or .NET list package with the vulnerable flag. That's going to tell us if there are issues. The package version, the CVE identifier, what version fixes it. There's a clear action, and that's the upgrade. So we want to do dependency scanning sometimes in our CI pipeline. That way developers don't need to manually check every package they install for vulnerabilities. New vulnerabilities are discovered daily against packages that maybe were safe yesterday, and automated scanning is going to catch them without anyone having to remember to look. So there can be some automation to this, and you can also do this, locally on your end. But keeping on top of your packages and not letting things go stale is a big way to improve your application security. The next one we're going to talk about is the AO3 injection. So injection happens when an untrusted input is embedded in a command or query without following some steps like sanitization, which causes the interpreter to execute unintended instructions. So we can see like this vulnerable Python query here. If the user enters or like 1 equals 1, you can see the example there, the query is then going to change and return every book in the database. And with a more malicious input, the attacker could delete data, extract credentials, or gain access to information they should not have had access to. So we always want to do what's called parameterization of queries. And this is where we set up kind of like variables so our input can be checked before it's added into the query. And that way the database driver will treat the input as data and not code, and the injection can't execute. So there's a lot of different ways we can protect ourselves from injection. The library app uses an in-memory data structure, not a database. So things like SQL injection isn't a current risk, but if you ever connected to a real database, then parameterized queries are kind of non-negotiable. If you checked this vulnerable code in somewhere where you work, they're going to give you some serious side-eye. There are other types of injection. I think SQL injection is probably the most well-known, but you can also have command injection, so passing user input to things like os.system or subprocess. You can have template injection, so we're taking user input and we're rendering it into HTML templates. So there's a lot of ways that a user with malicious intent can kind of break the rules of your application to get access to data they shouldn't, or even make changes to that data. So let's kind of just talk real briefly about AO1, AO2, and AO5. So AO1 was broken access control, and this is where a user can access or modify data that they shouldn't have permission to. So a little different from injection, where they gain access to it through some kind of injection attack. This is where we just didn't set up security on our folders or files. We're letting the user just browse things they shouldn't be able to have access to. In our library app example, if feature A, the member system, has a method that returns any of the members' checkout history without checking who's asking. So we can actually get information about any member and what books they've checked out, and the system doesn't actually check to see if we should be authorized to do that. So any user who knows or guesses another member's ID could then retrieve their whole history, right? So that's the kind of thing that we're talking about. So the fix in these kinds of situations is to always verify that the authenticated user is authorized for a specific resource that they're requesting. And it's not just that they're logged in, maybe that they're logged in with a, level of credential, like they're an admin, or that they have access to other users' records. AO2 is about cryptographic failure. So this is where passwords, tokens, and sensitive data are stored or transmitted in plain text. And as I was talking about earlier, this is what gets companies in trouble when bad actors gain access to their systems, maybe through an injection attack. They dump their SQL database, and then lo and behold, all of the data is in plain text. Passwords, credit card numbers, addresses, other personally identifiable information, and now they just have it all. So our example application doesn't handle any kind of authentication, but any system that does, we never store plain text passwords. We never transmit sensitive data over unencrypted connections. We really just check to make sure everything is hashed and encrypted and stored safely. And there's a lot of work that you can do to make sure that it's not just where the data is stored, but it's how the data moves in and out of that storage, because an attacker could gain access to it maybe on the client side or in transit. And so we just want to be careful about the steps that we're taking to secure that data. The other thing is AO5 security misconfiguration. So this is where security settings are left at maybe insecure defaults. So you have a debug mode on in a production environment. You've left default admin credentials on a system. You have extremely verbose error messages that reveal internal information that a bad actor could then use to piece together more ways to attack you. And so a stack trace that tells attackers exactly what technology you're using, what your file structure looks like, where exceptions occur, right? We want to turn off all of our debug mode things before shipping so that we're not exposing that kind of information. So some key takeaways, right? If you're not familiar with the OWASP Top 10, this is some standard vocabulary for web application security risks, and I recommend that every software developer get familiar with these different categories and start to learn about the ways that your application could be compromised and what the fixes are or the defenses are, because, cybersecurity is a big field now, and AI is only making that kind of worse. And as application developers, sometimes we feel like security maybe isn't our job. It's someone else's job. But if we're writing the code and we're implementing the systems, it is 100% our job to think about it. And there are lots of ways that we can put up defenses to help our friends over in cybersecurity. So we talked about some of those most relevant, but I mean, the top 10 are all relevant. But as a developer at this level, just learning about DevOps and quality assurance and testing, and maybe you're just getting started in the industry, these are the kind of the top ones that you want to look at and make sure that you're really covering your bases on. And so there's a second video I'll have that goes along with this, talking about DevSecOps. So how does security integrate into our CI pipeline? And we talked a little bit about how we can check for outdated packages as part of our pipeline actions. So we'll talk more about that in the second video. So I'd love to hear your comments. If you have any additional resources that you think would be good to share along with this, I always love learning about new security resources. So as always, thanks so much for watching. I'll see you in the next one.